Okay, welcome back. Today we're going to finish up graphing our exponential functions. Today we're going to focus on the ones that have transformations. So remember our a, h, and k pieces that we've been using to transform all different kinds of functions. We have a parent function, y equals b to the x power. And then yesterday we talked about this one, where y equals a times b to the x. And we had some numbers in front. That a piece, again, causes it to stretch or compress, and it reflects over the x-axis if a is negative. And then today, again, we're going to look at shifting left and right and up and down. Okay? So we'll take them in pieces. Let's first of all look at that stretch. We had a little bit of this yesterday. We're looking at y equals a times b to the x power. So we're going to let's start with just our parent function, where that a is just a 1, okay? Y equals b to the x is our parent. So let's look at 2 to the x power. We're going to start at the bottom. 2 squared is 4. 2 to the first power is 2. Anything to the 0 power, remember, is a 1. And if we raise things to the negative power, remember it's just the reciprocal. So if a positive 1 gave us 2, then a negative 1 is going to give us the reciprocal, 1/2. If a positive 2 gave us 4, when we flip it over for the negative version, we're going to get 1/4. Okay? Now, we have a 3 in front of ours. So let's look at what happens when we do that vertical stretch. So we're taking all of our y values that we found, our 2 to the x values, and we're multiplying them by 3. So our first one becomes 3/4, and then 3 times a half is 3/2, or 1.5. Again, if you want to think in terms of decimals, for graphing purposes, that's fine. The 1 gets multiplied by 3 to be a 3, 2 gets multiplied by 3 to be 6, and 4 gets multiplied by 3 to be a 12. Okay? So let's start with our parent function here. Y equals 2 to the x. At negative 2, we were up at 1/4. At negative 1, we were at a 1/2. At 0, we were at 1. 1 gave us a 2 for y, and 2 gave us a 4 for y. That was that parent function. Now, if we stretch everything vertically, okay, we made everything 3 times taller. So my stretched graph, instead of being at 4, I'm up at 12. Instead of being at 2, I'm up at 6. We had the point 0.3. We have negative 1 at 1.5, and negative 2 gave us 0.75. Okay? So you can see that my curve has been pulled and stretched a little bit, but I do want you to notice that we are still coming down and approaching that same asymptote that we had before. All right? The y-axis. Okay? So our y-intercept, again, is the value for y when x is 0, which ended up being a 3. And it's always going to be that 0, a. In this case, our a value was a 3. Our asymptote, though, stayed at the x-axis, which is that equation y equals 0. Our domain, just like yesterday, all real numbers. Our range, our y values are all going to be positive. They're going to be above that x-axis. So y has to be greater than 0. Okay? So what's changed from our parent function? Well, we had that vertical stretch. Our a value changed. Our y-intercept changed. Okay? But our asymptote did not. So with a vertical stretch, it is going to pull that y-intercept up or compress it down, but it does not affect the horizontal asymptote. Okay, let's look at one that has a negative in front. And this time our A value is a negative 0.5. So again, if you think about transformations, a negative is going to cause it to reflect over the x-axis. Okay, the negative A does that. And then the 0.5, the 1/2, is a vertical compression. Okay, so we should see this flipped upside down over the x-axis and then squashed to half its height. Okay, so we're going to go back and again, we're going to take out this 0.5 for a minute. We're just going to look at what does the parent function look like. Y equals the base to the x power. That's our parent. So y equals 3 to the x. So 3 squared would be 9. 3 to the first would be 3. Anything to the 0 is 1. 3 to the negative 1, remember we have to flip it over, so 1/3. And 3 to the negative 2, we have to flip it over and square it, so we get 1/9. And again, remember these are always going to be reciprocals of each other. Okay? For our new graph, y equals negative 0.5 times 3 to the x, we are taking our y values and multiplying them by negative 1/2. So 1/9 times negative 1/2 is going to be negative 1/18. 1/3 times negative 1/2 is going to be negative 1/6. 1 times negative 1/2 would be negative 1/2. 3 times negative 1/2 is negative 3/2, or negative 1.5. And 9 times negative 1/2 is negative 9/2, or negative 4.5. Okay, so again, if it's easier for you to think in terms of decimals, you can. Our parent function, we had points 29, 13, 01. Sorry, plotted that in the wrong spot. 13, 01, negative 1, 1/3, and then we were down at 1/9. Okay, now we are flipping these upside down and compressing them. Okay, so when x was 2, we had a negative 4.5. When x was 1, we had a negative 1.5. When x was 0, we had a negative 0.5. When x is negative 1, we were at negative 1/6, and then negative 1/18. So we're getting really, really close to that x-axis, but it's just going to be slightly underneath it. Okay, so we are curving up this time and approaching that x-axis from right underneath. All right, let's get this moved down a little bit there. Okay. It should be right under your x-axis. Okay, so let's identify some things. We want the y-intercept. Well, we are hitting the y-axis here at, when x is 0, y was negative 1/2. Again, it's always 0, whatever a is. The asymptote didn't change. Okay, it's still that x-axis that has the equation y equals 0. Our domain is always going to be all reals, but our range this time, I want you to look at your graph. Because we flipped this upside down, our y values are all underneath the x-axis. We're not ever going to go above it. So y has to actually be less than 0 this time. Okay, so what changed from the parent function? We flipped everything upside down. Our y-intercept changed, but again, our asymptote did not. Okay, let's look at an example that has a horizontal translation. This time we have this extra little, instead of just 2 to the x, we have 2 to the x minus 4. And remember, any kind of number inside with x is your left and right kind of shift. Okay? So we're going to graph our parent function again, y equals 2 to the x. 2 squared is 4. 2 to the first is 2. 2 to the 0 is 1. 2 to the negative 1, we have to flip that over and make it a 1/2. 2 to the negative 2, we have to flip it over and square it, so 1/4. Again, these are going to be reciprocals of each other. Okay? So let's plot the parent function. Negative 2, we are at 1/4. Then we're at 1/2, 1, 2, and 4. Okay? We are going to take those points now and we are going to shift them. Because it's an x minus 4, we are moving to the right 4. Okay? So we're going to take all our points and shift them right 4. So our graph is still approaching that x-axis, but it's just been moved off to the right. Okay, so what has changed? Our x minus h is going to shift it left or right. In this case, it shifted it right. If it had been x minus a negative value, so that would have turned into x plus 2, then we would have gone to the left. Okay? That caused our y-intercept to change. We've shifted everything over. So now we're trying to figure out, well, where exactly is this point? Because it's not a point we plotted. Our points that we plotted are over here. So let's go back and figure out, how do we find that point? So what we do is we actually say, well, the y-intercept is the value for y when x is 0. So let's put a 0 into our equation. Our equation is y equals 2 to the x minus 4 power. And if we put a 0 in here, we get y equals 2 to the 0 minus 4, which would be negative 4. And raising something to the negative 4th power means it has to flip. So instead of 2, we're going to have 1/2, and then it gets raised to the 4th power. 1 to the 4th is 1, 2 to the 4th is 16. So we're going to get 1/16 for our y-intercept. That's why it's so close to that x-axis. Our asymptote did not change, though. We're still at that x-axis, y equals 0. Our domain did not change, all real numbers. This time our y values are all above the x-axis. Our graph is going above the x-axis, so we're back to y having to be above that, greater than 0. All right, let's look at one more. This time we're going to look at a vertical translation. Our equation is y equals 8 times 1/2 to the x power minus 7. So again, our parent function is just the 1/2 to the x. We're going to start with that. Okay? So 1/2 squared becomes 1/4. 1/2 to the first power is just a 1/2. Anything to the 0 power is 1. 1/2 to a negative 1 has to flip it over, so it becomes a 2. And 1/2 to a negative 2 power is going to flip over and get squared and become a 4. Again, these are reciprocals of each other. Okay, so let's plot the parent function. At negative 2, we are up at 4. At negative 1, we're at 2, 0, 1, 1 1/2, and 2 1/4. Okay? Now let's look at what happens if we put that 8 in there. Okay, all of my y values are going to get multiplied by 8. So this 4 is going to turn into a 32. 2 gets multiplied by 8 to be 16. 1 gets multiplied by 8. Half of 8 is 4, and 1/4 of 8 is 2. Okay, so let's plot those points. We have at negative 2, we are way up at 32, which is off my graph. That's okay. We're going to have enough points. 16 is even off my graph. But let's get this one in there. 0, 8, 1, 4, and 2, 2. Okay? So remember, this point was way up here, way high. Okay? So we are coming down, leveling off at that x-axis. Now, we've taken care of the 8. We had a vertical stretch of 8. Okay? So we made that curve much, much steeper. But we still have this extra little minus 7 on the end, which is going to cause everything to shift down 7. Okay, so let's look at what happens there. This point at 0, 8 is going to go down 7 and land here. This point at 1, 4 is going to go down 7 and be here. The point at 2, 2 is going to go down 7 and be here. Okay, so my graph is now curving lower. The other thing that's really, really important is that your asymptote is going to shift down too. Just like all your points, your asymptote's going to move down as well. So we are going to have a horizontal asymptote here at negative 7. We moved it down 7 from the x-axis. So my points are going to come down here very steep, but they're still going to level off right above that horizontal asymptote. And it's really critical that you identify where that asymptote is so you know where your graph has to level off. Okay? Our y-intercept ended up being at 0, 1. Our asymptote, we said, moved down 7. So we're going to have the equation y equals negative 7 instead of y equals 0. Our domain didn't change. But our range now, all of our y values are above that asymptote. So they're above, greater than, negative 7. And hopefully you've noticed that there's a connection between those two. Your range is always going to be tied to where that asymptote is. All right. So what is the domain of all exponential functions of this form? Remember, our domain is all real numbers. Which transformations affect the asymptote of an exponential function? The only thing that's going to change the asymptote is a vertical shift up and down. Any kind of up or down movement is going to move that asymptote as well. Which transformation affects the range and how? It is tied to the asymptote. Okay, so we are going to be above the asymptote. So y is greater than whatever that k value is, as long as we didn't reflect anything. If we have a reflection, then we flipped everything upside down. Now y is going to be actually underneath that k value. Okay? All right, so you guys are going to be working on worksheet 7.1b, practicing these transformations of our exponential function.